Hello guys, welcome to today's class. So today we'll be talking about how to evaluate limits using the L'Hopital's rule. Using the L'Hopital's rule. So the L'Hopital's rule helps evaluate limits that result in indeterminate form like 0 over 0. This is an indeterminate form, and also infinity over infinity. This is also an indeterminate form. So the L'Hopital's rule helps evaluate limits that result in indeterminate forms like this and also like this. So instead of simplifying algebraically, and you just differentiate the numerator and the denominator, separate them, and take the limits. So all about the L'Hopital's rule is that you, instead of simplifying algebraically, like the way you do direct substitution, rationalization, and factorization, you differentiate the numerator and the denominator, then separately, differentiate them separately, then take the limit. So that's all about the L'Hopital's rule. So, but I'm going to guide you on how to apply the L'Hopital's rule step by step. So, for example, if we have lim f of x when x tends to a equal to 0 and the limit when x tends to a, g of x tends to 0, g of x tends to x approaches plus or minus infinity, and the limit when x tends to infinity, when x tends to a, g of x approaches, g of x is equal to plus or minus infinity. So that is when you will use the L'Hopital's rule. So, and it says that f when x tends to a plus or minus is equal to plus or minus infinity, then you applied the L'Hopital's rule. But g of x are differentiable. That means you differentiate the numerator and the denominator separately. Once you differentiate them separately, then you apply what? The limit. Okay, let me write it down in mathematical terms. The limit when x tends to a, f of x over g of x is equal to the limit when x tends to a, f prime of x is like differentiating f of x gives you f prime of x. This f prime stands for, it's still the same thing as the y dx. So on our next class, subsequent class, you understand better. You can, once you study all about differentiation, you can go back to how to evaluate limits using the L'Hopital's rule. So also g prime of x if the limit exists. So let's take one example, and I'm going to write the steps on how to apply the L'Hopital's rule. So evaluate the limit when x tends to 0 sine x over x. Sine x over x. So now the first thing to do, the first step is that substitute to check for to check for 0 over 0. If the expression will result to 0, first of all, substitute to check the expression result to 0. So if we substitute x tends to infinity, tends to 0, say sine x, the limit of x tends to 0, sine x over x equal to sine 0 over 0. Everything here will give you what? 0 over 0. So the next step, the next thing to do is to So the next thing to do, the next step is to differentiate the numerator and the denominator separately. So now, you differentiate the numerator and the denominator separately. So for the numerator, we have that if f of x is equal to sine x, then f prime of x is equal to cos x. So the derivative of sine x, if you differentiate sine x, you get what? Cos x. So on our next class, don't worry about this. On our next class, you will talk about differentiation, all about differentiation. You understand this better. So for the denominator is x. Let's call it g of x is equal to x. Then g prime of x is equal to 1. If you differentiate x, you get what? 1. So g prime of x is equal to 1. So we can say that the limit when x tends to infinity. So, okay, the third step says that take the limit of the resulting expression. Take the limit of the resulting expression. So you can start the limit when x tends to infinity. Sorry, when x tends to 0, sine cos x. We take the limit of resulting expression. So take the limit of cos x over x. This is cos x over x. So substitute is equal to cos 0 over, cos x over 1. Cos x over 1. Since we've taken we differentiated the numerator and denominator, cos x over 1. So we have cos 1 over 1. So this is equal to what? Cos 1. And cos 1 is equal to what? 1. So this is our answer. Our answer is what? Cos 4 is 1. So if indeterminate occurs again, so evaluate the limits when x tends to infinity. 3x squared plus 5 over 7x squared minus 4. So like I said, the first thing to do is to check if you substitute x tends to infinity into this expression, everything returns to what? Infinity over infinity. So now the next thing to do is to apply the L'Hopital's rule. Applying the L'Hopital's rule, say that if f of x is equal to, so the L'Hopital's rule states that you differentiate the numerator and denominator separately and take the limit of the resulting what? Expression. So you say that if f of x is equal to 3x squared plus 5 and g of x is equal to 7x squared minus 4. So we can say f prime of x is equal to, f prime of x means the derivative of this expression of f of x is f prime of x. So f prime of x is 6x. So if you differentiate this, you differentiate 3x squared gives you 6x. Differentiate plus 5 is what? 0. If you differentiate a constant is 0. So if we differentiate g of x, which is equal to 7x squared minus 4, we say g prime of x is equal to 14x. 14x. Now, the next step is to take the limit of the resulting expression. So taking the limit of the resulting expression. So our resulting expression is 6x over what? 14x. The limit when x tends to infinity. But x can cancel x, so we are left with the limit. Since there is no x, nothing to take limit here, or we can still further express that the limit when x tends to infinity of 3 divided by the limit when x tends to infinity of 7 is equal to 3 over 7. So this is our answer. So this is how to use the L'Hopital's rule. And using the L'Hopital's rule, so there are some things that why not to use the L'Hopital's rule. There are some, whenever you see some expression, you are not supposed to use the L'Hopital's rule. So those why you are not supposed to use the L'Hopital's rule is that when the function is indeterminate, when the function is cannot be differentiated, you cannot take the derivative of that function, so don't use the L'Hopital's rule. Instead, you can use either rationalization, can rationalize it and use other ways to evaluate the expression. So also when the form isn't indeterminate, when you see that this expression is you can just go straight to the point. It's not indeterminate, like it will not result to 0 over 0 or infinity over infinity. Don't use the L'Hopital's rule. So when a simple algebraic when you see a simple algebraic that can be factorized or rationalized, don't use the L'Hopital. So just go straight to the point and use the factorization method or rationalization method. I believe those ones can solve it more easier than using the L'Hopital's rule. So see you in our next class. Please like, share, and subscribe.